Hi guys, welcome again to our MPLAB XC8 tutorials. In this third tutorial, we're gonna learn how to read a switch connected to a PIC microcontroller. Switches are digital input and are widely used in electronic projects as most systems need to respond to user command or sensors. It's good to know how to read a switch because the same principle could be used to read a wide range of other digital input like a push button, limit sensors, proximity switches, or even a keypad, which is basically a combination of switches. Connecting a switch is straightforward. All we need is a pull-up resistor or even a pull-down resistor. Without this resistor, it will be difficult to determine the state of the pin. Let's say, for example, if a pin, let's say this pin RC0 is configured as a digital input and there's nothing connected to it. And if the PIC wants to read the status of the pin, will it be 5 volt or 0 volt? It's really difficult to tell. But with a resistor connected, for example, to VCC, this resistor is called pull-up resistor because it pulls the pin high to plus VCC. When the switch closes, the current will flow from plus 5 volt to ground, because the current always flows to the least resistant path, and the least resistant path is gonna be to ground. There's gonna be nothing going to the pin, and basically the pin is gonna be low. And when the switch is open, then this path is gonna be very high because it's open. Then the pin is gonna have 5 volts, so it's easy to read. It's either low voltage, which is 0, or high voltage, which is plus VCC. And the other thing, if there is no resistor, when I close up the switch, it's gonna be basically a short circuit because there is no resistor in the path. In this configuration, using a pull-up resistor, if the pin is low, it simply means the switch is closed. If I switch off the switch, the pin is gonna be low. And if the pin is high, let's say I've got plus 5 volt at the pin, it simply means the switch is open. Then it's easy to read the status of the switch. The next question we can ask ourselves, what should be the value of this pull-up resistor? There is no quick answer to this. The larger the resistance, the slower the pin in responding to voltage changes. This is because the system that feeds the input is essentially a capacitor coupled with a pull-up resistor. And as you know, a resistor and a capacitor basically forms an RC filter, which can take up some time to charge and discharge. On the other hand, if you select a lower resistance, when the switch is closed, there's gonna be more current that's gonna pass from positive to ground. And basically this is not a good idea, especially if the circuit is battery powered. Generally, 10K resistor should be fine. The other thing I would like to talk about is switch debouncing. Mechanically, metal contacts are not perfectly smooth. That's why when a switch closes, it doesn't perfectly close immediately. It bounces on and off so fast before it can stabilize and stay either open or closed. In normal situation, this debouncing period is so fast we can't even notice it. Let's say when you're switching on and off your light switch, normally you're not gonna see the light on and off before it stays on or off because this period is so fast. But a microcontroller can detect this. That's why we have to come up with a method to limit this bouncing effect of the switch. The easiest, as we're gonna see in the code, is to create a short delay. Let's say we use a delay of 10 milliseconds. If we read a switch, we give it a delay of 10 milliseconds and we read it again. If it's still closed after this delay, we can conclude that indeed the switch is closed. Let's go to the code and see how we can achieve this. Now we're gonna go to the code and see how we can achieve this. I just built a simple circuit. I've got one LED which is connected to port B0 and the switch is connected to port C0. When the switch is open, the LED is gonna be off, and when I close the switch, then the LED should go on. Let's go to the code. As we learned from the previous tutorials, to set the direction of the port, we need to use the trace resistor. In our case, port B bit 0 should be an output. I set it tri-state resistor to 0, and port C bit 0 should be an input to read the switch. I set its tri bit to 1. Still gonna use the internal oscillator, so I'm gonna use this oscon resistor. And in the while one loop, because I need my program to loop continuously, I'm gonna start to test if port C bit 0 equals to 0. Because I'm using a pull-up resistor, when the switch closes, I should have 0 at the input of the pin. Then I'm just gonna create a small debouncing delay to make sure that that effect of bouncing is finished. Then I'm gonna test again. If port C dot 0 is still 0, then I'm gonna use the LED resistor to output 1 at the port, which is basically is gonna switch on my LED. Else, if any else, then I'm gonna switch it off. Gonna build my program. The build is successful. Then let me go to the code and run the code, and it's working. If I switch off the switch, the LED goes off, and if I switch it on, the LED goes on. This is basically how you can read a switch. It can be anything, any digital input which needs an on and off status. It can be a switch, it can be a push button, it can be a limit switch, it can be anything. Thank you for watching, and don't forget to subscribe to our YouTube channel to receive more tutorials in the future. To learn more about this tutorial, please visit Reading Switches with PIC Microcontroller page on Student Companion. Thank you.